linear graphs are all about graphs of, oddly enough, straight lines. Remember, the trick to linear is that it has the word line in it. See that? There it is, line. So a straight line, you've probably seen this equation many times before, this y equals mx plus c form. Although sometimes your calculator uses mx plus b form, those two letters don't matter. What really matters is what's where. In other words, let's put it like this here. What you really care about is the order in which things are placed, or at least how they're placed. So for example, if we do something like this one right here, this m here, this m, do you remember what that represents? That represents the gradient. Okay, so we have the gradient here. Now we have this plus c. C is the, do you remember what that is? It's the y-intercept. So that means that's where it crosses the x-axis. Now this is just the generic form of it. It goes y equals mx plus c. What it just means is that if you have an x going on, anything in front of that x, that's m, and anything else that's left over, that's your y-intercept. So the letters themselves don't really matter so much as how they're placed. Now there is an alternate form for this. Okay, and this is also on your formula booklet here. This one here. This is just an alternate form for a straight line graph. And if you think about it, if you start with an equation like this, if you just moved everything over to one side and just got equals 0 remaining, like this, then this is it. This is actually this form. So I hope that doesn't confuse you too much. So if we look at this right here, like this, I see you have some graph paper, you must be plotting something, because we're going to do graphs. So let's look at this example here. For the line y equals 2x plus 3y minus 5 equals 0, what's the gradient? It looks kind of hard, doesn't it? But actually, all you have to do is, right now we're looking at it in this form. Okay, that's the form we're looking at. But we want it in that form. So the first step then is to get it in that original, or that nice form here. So I'm just going to rewrite in y equals mx plus c form. I think that'll be much more helpful. So let's actually try to do that. To do that, we have to just get y by itself. Let's see if this is going to work. So what we'll do, it doesn't matter what color we use. I'll use purple maybe. So this case right here then, let's look at this equation here. I want to move the other things to the other side. So if I want to keep my 3y to the left here, if I move my minus 5, actually let's move the 2x first. If I have a plus 2x, I want to move it to the other side. Do you remember what we do? It becomes a minus 2x. Because it's a whole term, right? We could subtract it away. And this plus 5, I get rid of it by doing the opposite. So the minus 5 becomes a plus 5. Now I've got 3y equals minus 2x plus 5. It's close. But you notice you're not allowed to have anything in front of the y here in this form. So what do I do to get rid of that 3? That 3 is multiplying the y, so to get rid of it, I divide by 3. So weirdly enough, that means I have to divide everything by 3, including the 5. So this is now my equation in y equals mx plus c form. Why is that helpful? Well, that's because now I can see the gradient directly. Look, anything, remember that rule there. If you get it in y equals mx plus c form, which this is, anything in front of the x is your gradient. So in this case right here, then, what's in front of the x? There's that minus 2/3. Now, of course, you could do that on your calculator if you wanted. Right? So you can just open up a new page, calculator, and just do minus 2 over 3, and you should get like 0.67. Let's just see here. Yeah, so minus 0.667, let's just say. So equals minus 0.667. So they're both correct. This is technically better just because it's the full solution, but this is rounded. You can use that on your calculator. There you go. Let's go a little bit deeper into this. So if we talk about this one here, I like this t-shirt, by the way. This is going to be the equation of the gradient. Some people call it the slope. That's why it's like hit the slopes. So this equation also is given to you. Now, you can find a gradient by using 2 points. You know, if you have 2 points right here, this one right here would be called like x comma y. Those would be its coordinates. This one has coordinates x, y. So if we're going to call these 2 points, we can call this point 1, we can call this point 2, which means everywhere we see this one here, we put little subscripts, x1, y1, and this one we'll call x2, y2 then. If we define it like that, then the gradient can be seen as y2 minus y1 over x2 minus x1. And this you do not have to memorize. This is given, which is great. Now, some people prefer another formulation. Some people like to call it rise over run. You might have heard that way. That's just because that reminds you that it's how much it goes up divided by how much it goes across in the x-axis. Some people like to use this formulation, delta y over delta x. That's also correct. It's all the same thing. Look, delta means change. The change in y is your y2 minus y1. So can you see how we have this equation m equals delta y over delta x, which is this, which is hit the slopes, because that's the slope or the gradient. Now the y-intercept, that's something else that's needed. And remember, that's just where it crosses the y-axis. So what does that mean? That's a physical thing, right? That is the y value where it does cross. So let's see if we can do this equation right here. Write an equation in the form y equals mx plus c for the following. So we're given a graph, and we need to get the equation for it. These are harder. See, if they give you an equation, they want the graph, you could do that as well, but you could also do that on your calculator. Here, this is a little bit harder because this is harder to do on your calculator. That's why they prefer this on exams. These kind of things show up a little bit more. So let's look at this. Maybe I need 2 points. I like to choose points where things are really nice and easy. So can you see this part right here is maybe a good one? And if you look at this right here, it's a little bit hard to see, but there's also one that's decent here. Look, this one right here. I'll put it down here, and this one right here that goes across here. That's a good point, so I can use that one there. Now if we put these coordinates here, this right here would be x is 4. Whoops. The x value here is 4. The y value is 5. So this would be your x2, y2. Over here, what's this one? X is 0. Whoops. So this is 0, comma 3, because the x value is 0 and the y value is 3. So this will be x1, this will be y1. So one way to find the gradient, because we'll need that, one way to find the gradient would be just to use this equation then. Well, that equals m, which equals, and you write this down, right? Because you show your examiner, you know what you're doing on your exam here. You say, I know what I'm doing here. Fine. Then I take this, I just put in my values here. So what do I get here? I've got y2, which is 5, minus y1, which is 3. So I've got 5 minus 3 over, and for the x's, I put in, I just made that really unclear. I'm just not very happy with my 3 there. There we go. Over x2, which is 4, minus 0. Again, I don't know why it's doing that. There we go. Sorry for taking longer. There we go. So what's that? 5 minus 3 is just 2. And 4 minus 0 is just 4. So that just gives you 2 over 4, which is actually 1/2. You could leave it as 1/2. You could leave it as 0.5 if you want. They're both okay. Basically, your gradient is 1/2. Now, your y-intercept, luckily, that's real easy. You know what that is? Your y-intercept, it's where it crosses the y-axis. Look here. It's at 1, 2, 3. So that's just at 3. What does that mean? Well, that means that this is your c value, this is your m value. Because remember, the thing in front of the x is always the gradient. And the extra thing that's laying around is the y-intercept. So finally, then, I could state, without any doubt, that y equals mx plus c, where m is 1/2. And c will be 3. So we'll do 1/2 x plus 3. This is my final equation. Now, of course, you could take this then and test it with your calculator. So you can open up a calculator, for example, and you can say, all right, well, I'll open up a new page. Maybe I'll do a graph. And I can actually put in this one right here. So I can put in 0.5 x. That's the same as 1/2, by the way. Plus 3. I can say enter. Let's just really see if this works. If I do a trace, so I do menu and I'm going to do trace. If I just want to trace this graph, if I put in x equals 0, I just type in 0, I get that y is 1. Is that, 0, I get y equals 3. See that? 0 is 3. 0 and 3. That's good. That matches. If I put an x equals 4, I'd better get y equals 5. Let's try it. I type in 4, and it tells me, phew, y is 5. That's how I know I've done this correctly. So you can actually test your answer with your calculator, but your calculator won't necessarily easily do this. That's actually a lie, because you can plot these 2 points on a graph. You can actually have a graph thing actually plot these 2 points and ask your calculator for the straight line in between them. So you can kind of cheat too. But at least this is a way to do it. And I hope you see that's pretty straightforward. Another way to have looked at this would have been to recognize that from here to here, this right here we can call delta y, and over here to here we can call it delta x. And then you just think, all right, isn't it rise over run, delta y over delta x? So watch, how much do you go from here to get to this point? How much do you go up? You go up by 2, and you go over by 1, 2, 3, 4. So that's how you know it's 2 over 4. There's a couple of ways to looking at it. I think that explains most of it. I hope that helps.